The average price of 3 bags are 10 rupees, 12 rupees and 15 rupees. So there are 3 bags, B1, B2 and B3, which cost 10, 12 and 15 rupees on an average. Now we are given the average price of bags 1 and 2 taken together. It's 10.5 rupees. And we are also given the average cost of bags 2 and 3 taken together, 13 rupees. With this, we are asked for the average price of all 3 bags taken together. Now to find the average price, we need to find the weights of the bags or the ratio of the weights of the bags. And don't forget, allegation works only for 2 quantities. We cannot write it like this for 3 quantities. It won't work. So how do we find the ratio of the weights of the 3 bags? First, we have been given the average price of bags 1 and 2 taken together. So let's find the ratio of the weights of these 2 quantities first. The individual average prices are 10 rupees and 12 rupees. And the combined average price is 10.5 rupees. Now we can easily get the ratio here using the allegation concept. 12 minus 10.5 is equal to 1.5 and 10.5 minus 10 is equal to 0.5. This is the ratio of the weights of bag 1 and bag 2. It can also be written as 3:1. Next, we are told about bags 2 and 3. The individual average prices are 12 and 15 and their combined average is 13 rupees. Pause the video and find the ratio of the weights of bags 2 and 3. "15 minus 13 is 2 and 13 minus 12 is 1. That's the ratio of weights of bags 2 and 3. But now we come to the important part. How do we find the ratio of the weights of bags 1, 2 and 3? It's actually very easy. The ratio of weights of bags 1 and 2 is 3:1 and that of bags 2 and 3 is 2:1. The common one is bag 2. So we try to make that part of the ratio same. 3:1 can also be written as 6:2. And this gives us the ratio of the weights of the 3 bags as 6:2:1. This is the ratio we wanted. We already have the individual prices, and this ratio of weights will give us the overall average price. Let's call it the resultant average. We apply the weighted average formula A1N1 plus A2N2 plus A3N3 divided by N1 plus N2 plus N3. We have A1, A2, A3 and N1, N2 and N3. The resultant average price will be 10 times 6 plus 12 times 2 plus 15 times 1 divided by 6 plus 2 plus 1. 60 plus 24 plus 15 is 99 and this sum is 9. That gives us the average price of all 3 bags together as 11 rupees. That's how we solve allegation problems with 3 quantities. We will look at one last example of this topic in the next video. This is our last problem based on mixtures and allegations, and it's a tricky one. We have 2 alloys in which the ratios of lead and tin are 2:3 and 1:4. What is an alloy? An alloy is a metal made by combining 2 or more metallic elements. In both these cases, the alloys are made by combining lead and tin. We mix 4 kilograms of alloy 1, 6 kilograms of alloy 2 and some kilograms of pure tin. We are not told how many kilograms of tin we are mixing. And after this mixing, we get a new alloy which has 20% lead. And guess what we're asked for? You guessed right. We are asked for the weight of pure tin that was added. 3 things are mixed here: alloy 1, alloy 2 and pure tin. And that will give us a new alloy which has 20% lead. And the remaining 80% will obviously be tin. And we are also told the weights of alloy 1 and alloy 2. How do we find the weight of pure tin that was added? Don't forget, allegation will not work for 3 quantities like we see here. But we can apply allegation to 2 quantities. Let's try that first. We are told about 2 alloys here. Let's call them alloy 1 and alloy 2. And the third quantity that we mix is pure tin. Because we have the individual ratios and the individual weights of the two alloys A1 and A2, let's apply alligation to it. Let's write down these three quantities with respect to lead. The ratio of lead to tin in the first alloy is 2:3, so the lead proportion will be 2 over 2 plus 3, which equals 2 over 5. And for alloy 2, the ratio of lead to tin is 1:4, hence the lead proportion will be 1 over 1 plus 4, which equals 1 over 5. And we also have their individual weights as 4 and 6. We need to find the resultant average here. Now the ratio of N1 to N2 can be reduced to 2:3. To find the resultant average here, we apply the weighted average formula. Don't forget the rule of thumb. Want to find the resultant average? Use the weighted average formula. And if we need to find the ratio, use the alligation concept. So using the weighted average formula, this is what we get. A1N1 plus A2N2 divided by N1 plus N2. Solving this will give us the answer as 7 over 25. That is the resultant average here. That's the lead proportion of the mixture of these two alloys. Now it gets interesting. As all three are mixed, we apply alligation again. On one side we have A1 plus A2 and on the other we have pure tin. These are the three things we are mixing. Again, let's write all quantities with respect to lead. We have already found the lead proportion at this point. It's 7 over 25. And what will be the lead proportion in pure tin? It's easy. As it has no lead, the lead proportion will be 0. And after these three quantities are mixed, what is the final lead proportion? We are told that it's 20% lead. That can be written as 1 over 5 in fraction form. Now, because the fraction on top has 25 as its denominator, let's write this as 5 over 25. With this, it is very easy to find the two weights here. 5 over 25 minus 0 is 5 over 25, and 7 over 25 minus 5 over 25 is 2 over 25. This is the ratio of weights. Simplifying the ratio gives us 5:2. We need the weight here, so how do we find that? Do we know the weight of A1 plus A2? Yes, it's 4 kilograms plus 6 kilograms, that's 10 kilograms. If 5 corresponds to 10 kilograms, then 2 will correspond to 4 kilograms. That's the answer. 4 kilograms of pure tin was added. But wait, was this the best way to tackle this problem? Or is there a better way? Can we use the weighted average formula directly? The weighted average formula for three quantities says that the resultant average is equal to A1N1 plus A2N2 plus A3N3 divided by N1 plus N2 plus N3. Here A1, A2 and A3 are not alloys, they are averages. Which of these values are given? Let's consider these four values with respect to lead. We have A1 as the proportion of lead in the first alloy. That will be 2 over 5. A2 will be the proportion of lead in the second alloy. That will be 1 over 5. And A3 will be the proportion of lead in tin, which is 0. Do we have N1, N2 and N3? N1 is the weight of the first alloy, which is 4 kilograms. N2 is the weight of the second alloy, 6 kilograms. And N3 is what we need to find. Let's call it X. And what about AR? Do we have AR? Yes, it's 20% lead or 1 over 5 lead proportion. Now pause the video and try to find X. After substituting the values in the formula, this is what we get. And to make calculations simpler, we multiply this equation with 5 to get this. And transposing 10 plus x to the other side, we get 10 plus x equal to 8 plus 6. And that gives us the value of x as 4 kilograms. That is the weight of pure tin that was added. We got the same answer, but much faster. So this brings us back to the most important point. Don't blindly use alligation. take a moment and analyze which method is suitable for the problem. With this, we complete the topic of weighted averages, allegations and mixtures. If you have watched all our videos, I can assure you that you will be able to tackle all problems with ease. Good luck!